And good morning. Here are some examples of writing the equation of a uh, sine function from a graph. So we're going to be looking at a graph and trying to write the equation for it. And here's our first example. So the general form for a sine equation should be y equals some a value, sine, a b value, x minus c, plus d. And let's just refresh what these values do. So the a value affects the amplitude, and more specifically your amplitude is always positive, so it's the absolute value of a. Your b value changes your period, so your period is always 2 pi divided by the b value. Your c value is the phase shift, so it's going to affect the graph by shifting things left or right. And your d value is your vertical shift. So it's going to affect the graph by moving things up or down. So when I'm doing these types of problems, I kind of just think of it as kind of going through and kind of make a shopping list, and you just need to find your A, B, C, and D values, and then you can put it into the final form. After you find your different values, you can then go write your final form. So let's go ahead and get started on one. So we're going to go through and find A, then B, then C, then D, and you don't have to do it in this order, but you do need to find all four values. So the first thing I always start with is the vertical shift. So if you find the midline of the graph, the midline, unless there is a vertical shift, the midline should always be on the x-axis. So it looks like this is the high, this is the low, so your midline will be right here. So the vertical shift off of the original midline is 0, so your d value is going to be 0. And your amplitude, so if we're looking at this as a sine wave, so your amplitude, it goes as high as 1. So it goes as high as 1 and as low as -1, and that's the normal amplitude for a parent function, or a fundamental parent cycle of your sine wave. So the a value is not changing off of the original parent function. So a is just going to be 1. And it's a right side up sine wave. So it's not upside down, so we're not going to put -1. Sometimes you might be looking at a upside down pattern of the sine wave and you'd want a negative there. Your b value, so we know the period is always 2 pi divided by b. So how long is one period? So it's going to go from -2 pi all the way to 2 pi to make one cycle. So that's about twice as long as a original cycle for the parent function. So from -2 pi all the way to +2 pi, that's going to be a period of 4 pi. So the period is 4 pi, so we need to use that to go find the b value. So the b is not going to be 4 pi. We know the period is 4 pi. So we'll put that in for the period. And solve for b. So you can cross multiply or multiply both sides by b, however you want to think of it. So 2 pi times 1 is 2 pi, and b times the 4 pi. And divide by 4 pi. So your pi's are going to cancel. And you're left with a b value of 2 over 4, which is a half. So b needs to be 1/2. And the last part is the phase shift. So we know that a normal sine function starts at the origin. It looks like this one, the starting point went back, negative 2 pi. So your c value is going to be negative 2 pi. And once you have your a, b, c, and d values, you just want to put that into the final equation. So your final equation, y equals, our a value was 1. So you can put that in or just realize it's 1 if you don't put a number there. So we have 1 for the a. Sine, our b value was 1/2. And then it's x minus c. So it's going to be x minus the minus 2 pi. So 2 negatives in a row is going to make that plus. So plus the 2 pi, since it's minus minus. And then your d value is 0. And again, in an answer key, you probably won't see the 0. You can simplify that down and just not have a number there. And you probably wouldn't see a 1, since if there's no number in front, it's assumed to be multiplied by 1. And here's another example. So again, we'll find a, b, c, and d. I usually start with the d value first, so kind of get your bearing straight, find the midline. So the graph goes, looks like as high as 1 and as low as negative 3. So the center of the graph will go right through here. So it looks like your midline is at y equals negative 1. So your vertical shift, it went down 1 off the x-axis. So we have a vertical shift of negative 1. The a value, we need to pick out a sine pattern. So a sine wave normally starts on the midline, so I would look at this pattern. So if we focus on this portion of the sine wave, then what do we have for an amplitude? So how high off of the midline and how low off of the midline does it go? So it looks like it goes two units above the midline and 2 units below the midline. So it's going to be 2 for an amplitude. And we're looking at a right side up sine wave. So this would be the normal sine wave pattern. It's right side up. So it's going to be positive 2. Not all students will look at the same part of the graph. For example, another student might pick up on this portion of the graph. So another student might see the midline here, but they might focus on this part of the graph. If they were focusing on this part of the graph, that would have to be a negative a value because it's upside down. And then they're going to have a different phase shift since they shifted to the left all the way back to here instead of shifting to the left back to here. So there are different answers when you're writing the equation of a sine function. So let's go back and just look at the one that we were looking at. And we are focused on the right side up. sine wave. And let's find the period. So it looks like the cycle starts here and it gets to the end of the cycle here. If you notice the scale, every tick mark looks like it's a quarter pi. So that's going to be 1/4, 2/4, 3/4, 4/4. So the period to make one cycle was 4/4 pi, which if we simplify is just pi. So it looks like the period is pi. And we know the period in relation to the b value, the period is always 2 pi divided by the b value. So in this case, our period length is pi. And then solve that for b. So you're going to get 2 pi is equal to b times pi. And then solve for b, so divide both sides by pi. And your pi's cancel, so divide by pi, and you're going to get 2. So your b value will be 2. And the final thing is the phase shift. So if we're starting our function here, if this is how we envisioned it, so we're starting it right here. So how much did it shift off of the y-axis where it normally starts? It looks like it went back pi over 4. So we'll say the phase shift is going to be negative pi over 4. And then we can go ahead and put it into the general form. So we're going to get y equals 2 sine. The b value is 2. X minus the c value, so x minus minus makes it plus, and then a d value of minus 1. And here's one more example. So let's find our a, b, c, and d values. So let's find the midline first. So it looks like it goes as high as 10 and as low as negative 10. So the midline will be the x-axis, y equals 0. So there will be no vertical shift. So d is 0. And let's find the sine wave pattern that we want to work with. So the sine wave always starts on the midline. So if we start here, this is going to be the beginning of a sine wave. And then it kind of stops in their graph, but if it kept going, that would make one complete sine wave. So the a value, it looks like from the midline it's going to be 10. 10 in either direction from the midline, so the a value is going to be 10. But if we're going to be writing the equation for this particular cycle, if we start here, notice it's a upside down sine wave. It goes down, then back up. So we're going to need to put a negative on that. So it's going to be a negative a value to make that upside down. The b value, we need to find the period. So to find the period, you just need to look at how long the graph takes to make one repetition. You don't have to look at our particular sine value if it's not convenient. You can just look at any part of the graph and see how long it takes to repeat. So notice, since we don't see our whole sine wave from what they drew, it might be a little bit difficult to look at that, but we just are looking for one repetition. So it might be a little bit easier to look at the cosine pattern. So notice this is a cosine pattern, and you could write this as a cosine function. We'll do that at the end. So how long does it take to make one rotation or one repetition? It looks like it goes from 0 to 8 to make one repetition. So your period is going to be 8. So we know the period is 2 pi divided by b, and our period is 8. So we can put 8 in for the period. Cross multiply and solve for b. So b is going to equal 2 pi divided by 8. So b is going to be pi over 4. If you simplify, and the last value we need is the phase shift. Since we're writing our equation particular to this particular sine wave pattern, then how much did it shift? So it shifted off the origin. It looks like it shifted over 2 according to their scale. So it's going to be a phase shift of 2. And that should get us all of our values, so then we can write the equation. So if we're writing it as a upside down sine wave, the yellow one, it's going to be y equals -10 sine, and let's see, pi over 4, might run out of room, let's see if we can fit it in. So the b value was pi over 4, x minus the c value, so -2, and we don't have a d value, so it looks like it's going to fit. So there's one possible answer. There are technically an infinite number of answers for these because people can look at them as sine waves, as cosine waves, right side up sine waves, upside down sine waves. They all would just have a different phase shift to get the graph to line up to where they want it. So for example, we could write this as a cosine function. So let's look at that. When you write them in different forms, pretty much everything stays the same. The only thing that can really change is the phase shift. So the phase shift can change depending on how you want to orientate the graph. And the a value can change a little bit. It's still going to be 10 or -10. So the only real difference is it could be positive or negative. So if we looked at this as a cosine graph, so if we looked at it from here to here as a cosine graph, the d value is still going to be 0. So let's see how things change. So we'll say A, B, C, and D. The midline is still on the x-axis, so your d value will still be 0. Your a value is going to be 10. Your amplitude is still 10. That's the height of the graph. But it's not upside down. Since we're not looking at an upside down sine wave, it's actually a right side up cosine wave. So it's going to be a positive cosine wave. So that's going to be positive 10. Your period length is still 8, which means your b value will still be pi over 4. And your c value, cosine normally starts on the y-axis, and that's where this one is starting. So your c value in this case is actually 0. So when you are writing them using different functions or different phase shifts, pretty much the only thing that could be different is the phase shift to put it in the right spot, and the a value to decide whether you're looking at it as an upside down cycle or a right side up cycle. So an alternative answer, you could say this is y equals right side up cosine, so 10 cosine, the b value to change the period, and then it's x minus the c value. So x minus 0 would just be x, and then your d value is plus 0. So that would be another equation. If you graphed both of these on your graphing calculator, they would basically graph right on top of each other. So they're the same sine or cosine wave, just expressed differently, using sine versus cosine and using a different phase shift. And I believe that is it. Those are your examples for writing the equation of a sine or a cosine graph using a picture and then making the equation, and I will let you go.